Okay, everybody, today we're going to start our last chapter in the circles or circle geometry unit, and we're going to tackle angles and circles. I think this is by far the most confusing part of this unit, so if you do need help, let me know. First, we got to get into a bunch of vocabulary that you might not be familiar with. So the first thing we're going to learn is major and minor arcs, and the term arc is a section of the circumference of a circle, which in plain English is just some amount around a circle. So you could say between point A and B, this is an arc going around the outside. You could say between uh, A and B going the other way, this short side, that's also an arc. You could say between A and C, there's an arc here. There's also an arc all the way around this side. So arc is basically just 2 points, and then it's the area around the outside of a circle between those 2 points. Keep in mind you can go on either side of those points, and that's where minor and major arc come in. So a minor arc is a shorter arc between 2 points on a circle, and a major arc is the longer arc between 2 points in a circle. This should be moved over a bit, sorry. So now let's talk about central angle. So the central angle is formed when you connect the ends of an arc to the center point of a circle. So if you take A and B as our endpoints of an arc and we connect it to the center point of the circle, our central angle is right in there. It's the angle that butts up against the center point of our circle. So in this picture, the central angle is APB. An inscribed angle is something different. So an inscribed angle is formed when you connect the ends of an arc to another point on the circle. So if you have ABC, angle ABC would be called an inscribed angle. If you went AOC, that would be our central angle. Then I think this is the last one. Yeah. So subtended is our last piece of vocab. And in this example, the inscribed angle ABC, so our inscribed angle here, is subtended by the minor arc AC. So subtended is just kind of a fancy word for something being within the endpoints of a set of lines. So the angle here is subtended by this arc. It's in the endpoints of the lines that create it. So now let's talk about a couple properties that we can use to solve some math problems around this kind of stuff. The central angle and inscribed angle property. So in a circle, the measure of a central angle subtended by an arc. We're going to have to say that again. In a circle, the measure of a central angle, so right in here, subtended by an arc, subtended by this arc, is twice the measure of an inscribed angle, this guy here, subtended by the same arc. All these properties are very confusing, or written in what I consider to be fairly technical language. So I put an in English section for all of them. The central angle is 2 times the size of the inscribed angle if they both have the same endpoints. So this angle is twice as big as this angle if they both have the same endpoints. That's how I like to think about it. I don't know. Oh, I think I skipped one. No. So the inscribed angles property. In a circle, all inscribed angles subtended by the same arc are congruent. And congruent just means equal. So in English, if multiple inscribed angles share endpoints, the inscribed angles are equal. So if we have DAC and we have DBC, you know these are going to have equal angles because they have the same endpoints, so they're creating the same angle. It doesn't matter where that middle point is. A and B could be anywhere, and they would always share the same angle. Then we have diameter and angles in a circle. This isn't a property in and of itself, but it's an important thing to kind of think about. Now, you guys probably would be able to figure this out if you thought about it long enough, but we're just going to talk about it and it'll lead us into the next property. So it's important to note if you have an inscribed angle connecting the points at the end of the diameter, you'll have a central angle of 180 degrees. So if you've got ACB, this central angle right here is 180 degrees. And if you have 180 degrees, you know your inscribed angle is 90 degrees. You know this would be 90 degrees. And as soon as you see something 90 degrees, when you're talking about angles, you need to assume that you're going to be using Pythagorean theorem because, I don't know, mathematicians love that. You could also, if you know this is 90 degrees, figure out what angle CAB is. You could figure out this angle in here because you know that all these should add up to 180. So this gives us the last property, which is angles in a semicircle. So all inscribed angles subtended by a semicircle are right angles. And when a question says semicircle, it just means the circle's been split in half. So one of the lines is acting as the diameter because it splits it into two halves of a circle. So this is, I think, a really good little chart to keep up if you're having trouble with this. To keep this up while you're doing your work. You can access it on the PowerPoint, or you can just pause the video here and use this as a reference. But it goes over all three of them, just really brief language. So the semicircle rule, right, our inscribed angles rule, and our central angle versus inscribed angles rule. I know that was a bit of a shorter one with a lot of information, so feel free to watch it again. But we'll do a bit of practice, and you can always bounce back and forth between the practice and the video. Cheers, guys.